what you can do, instead of finding the antiderivative in terms of u and replacing the u with what it is in terms of x to have it match up here, to have the changing the u's so it matches up with the x's, we're going to change the x's, the lower and upper bound, so it matches up with the u's, and then we can just forget about x completely, because if you notice, our answer doesn't have anything to do with x. Our answer is 15/8. So it doesn't matter if we use a u or an x to get there. No one will know the difference, essentially. So we can go back up here where we split off, and I can do, let's see. What I'm going to do is actually, I'm going to replace x's with what it is in terms of u. So when x is 1, what is u? And this is where we go back to our, let's see, u equals x squared plus 1. So when x is 0, like in the lower bound, we have u equals 0 squared plus 1, or 1. And when x is 1, we have u equals 1 squared plus 1, or 2. So really going from x is 0 to x is 1 is the same as going from x is 1 to x, same as going from u is 1 to u is 2. So going from x is 0 to x is 1 is the same as going from u equals 1 to u equals 2. So I can rewrite that definite integral as 1/2 u cubed du, going from u equals 1 to u equals 2. So I changed my upper and lower bounds to not be in terms of x, but to be in terms of u, and now I can just forget about x completely. Let's see if we get the same answer. So this is what my problem looks like now. The antiderivative of this, again, is, I'm going to go ahead and simplify it, 1/8 u to the 4th, right, plus c. That's the antiderivative. And we want to do this from u equals 1 to u equals 2. So notice how it's different from on the left. I don't have to write in, sub in the x squared plus 1 for the u. I can just apply the fundamental theorem here. So it's going to be 1/8 2 to the 4th minus, I can forget about the plus c again, 1/8 1 to the 4th. And notice that's what I got in this other step here. So the answer is the same, 15/8. So you kind of get out of, it's less, this side, the right side, doing it this way is less complicated than the left side, and you get the same answer, 15/8. Okay. I'll tell you what, let's look at this graphically. Because what is 15/8? We always want to remember what these represent. What does this definite integral represent? I'm going to look at its graph, and I've got this kind of nifty graphing program here. I'm going to look at its graph by typing in x times x squared plus 1, plus 1 cubed. Whoa, oh, I need to do y equals, whoops. Okay. That's what the function looks like, and we're doing the integral from 0 to 1. So we're looking at the area underneath the curve of this function from 0 to 1. I'm going to draw a quick sketch of that. Draw a quick sketch right down here. Okay, so if I graph that function, let's see. You saw it looks something like this, more or less. This is just a sketch, so I'm not too worried about it. Looking at it from 0 to 1, so we're looking at this area, which we said that area was equal to 15/8. Okay. Now the interesting thing is that this integral that we saw, was actually equal to another definite integral. This one here. The definite integral of 1/2 u cubed du from u equals 1 to 2. So I'm going to write that down. U cubed. These two are equal. From 1 to 2. So I'm actually going to look at what does 1/2 u cubed du look like. Or 1/2 u cubed, just that function. I'm going to plot it just as a function of x to make it simplified here. Okay, so I'll just say 0.5 x cubed. Looks kind of similar, right? It's a cubic. And we're looking at it from 1 to 2. So I'm going to just draw a quick sketch of that. By the way, if this is the x-axis, I guess this would be the u-axis. So this is our f of u. It looks pretty much the same in my little sketch, but this is supposed to be y equals 1/2 u cubed. And this is supposed to be y equals x plus x squared plus 1 cubed. And now we're looking at this area from 1 to 2. Turns out that area is the same. It's also 15/8. So that's like a visual kind of for what we did. With this change of variables, we had this kind of complicated looking integrand for our definite integral. We made it less complicated. And there's this sort of geometric interpretation of that. All right, I'll let you guys do the next example on your own, and you can email me or send me a message in the chat room if you have any questions. Thanks a lot.